Let's deal with issues with rational expressions. First, we're going to start with subtracting one set here. What we're going to look at is first simplifying it. There's a big, long, hard way to do this, or if you take this and simplify it, it becomes a little easier. X minus 2, and on the bottom, we have x plus 2 and x minus 2. So factoring this right off the bat is going to help us. In fact, this one, x squared plus 4x plus 4, is x plus 2 squared, and I'll write that as 2x plus 2's. But here we can see that these cancel. So in place of x minus 2, I have 1. So 1 over x plus 2 minus 3, x plus 2, x plus 2. We cannot add or subtract fractions without the denominators being the same. So that means I'm going to have to multiply this one by x plus 2 over x plus 2. And in parentheses, all this. So that gives me x plus 2 on the top. And here it was minus 3 and x plus 2's. Now actually, x plus 2, because the denominators are all the same, I can now just do x plus 2 and x plus 2. And it's x plus 2 minus 3, so that means 2 take away 3 is 1. So it's x minus 1 over x plus 2 and x plus 2. Doing it as x plus 2 squared would have been acceptable too here. Now, I don't have it written here, but I'm going to do or talk about a possible and probable mistake that people tend to make on one. So I'm going to rewrite a different one. I'm going to do x plus 2 over 7 minus x plus 6 over 7. So we have the same denominator here. Okay. I'm going to put parentheses there because that's going to make a big difference. In fact, if I don't put parentheses, there tends to be an error, and you don't always see it with parentheses. So let's take a look here at what happens. I have the same denominator. So it's almost as if I've already done some work and I've gotten the same denominator on the bottom. So I have the 7, and so I have x plus 2 minus x plus 6, and I just made a mistake on purpose. I purposely made a mistake right there, so don't make that mistake. I put a plus when what I should have been doing was doing minus times that and minus times that, so it's supposed to be a minus 6. I quickly got rid of it because I wanted you to see the error as if I'd forgotten about it, but I don't want you to do that error. So what you have to remember is that what's happening up here is that that's minus x plus 6 in parentheses. When you're subtracting like this, you're subtracting each thing on top separately, individually, not just the first one. So it's like a minus 1 times x and a minus 1 times 6, so it becomes a minus 6. All right, so that means our answer will be x. Take away x. Ooh, the x's will cancel out, and 2 take away 6 makes that a negative 4 over 7, which makes it a negative in front of 4 over 7. So that becomes a simpler problem, but it identifies what I wanted you to see here. You have to be really careful with the sign. And if you're careful with the sign, you won't have any problems with this and won't make any mistakes with that. Okay, let's go down and take a look. This is the same problem as above, except that it's dividing now. So let's look at what we do. Remember, when you divide a fraction, you simply do times. In fact, I'm going to factor this while I go here. So the dividing becomes times, and what was the denominator, or what was the numerator becomes the denominator, and what was the denominator goes up top as the numerator, which is x plus 2 times x plus 2. Saving trouble here by just factoring that right now. X plus 2, x plus 2. Okay, now that it's times, we have this problem here, And it allows us to do lots of canceling. First, the x minus 2 and x minus 2's cancel, and I have a 1 there. Because it's times, I can cross cancel that. Okay, those x plus 2's go away, replaced by 1's. And all I have left is an x plus 2 on top and a 3 on the bottom. Well, fine. That means that's all I have. That's the answer. Cool. Done with that one. Now, here we're going to talk about dividing rational expressions when it's in a different form. And let's take a look at this first one. We have fractions inside fractions. You can get rid of them by multiplying by 1. That x that's on the bottom, I'm going to multiply by x. I'm going to multiply by x over x. That's 1. But I'm going to do it as x over 1 and x over 1. X over 1 over x over 1 is the same as x over x, so it's still number 1. So I'm going to distribute it here, and I get 3 times x minus 4, because now here the x's cancel. Let's put that dot back there for the multiplying. And on the bottom, I get the same thing, 3 times x, and the x's cancel. And that's it. I can't do any more with that. That's the answer to that one. Okay, so I'm going to fill that one in. Because they're in parentheses, because it's grouping symbols here, that's 3x minus 4 and 3x plus 4. I can't cancel out the 3x over 4. Now look at this next one. Here the things are reversed, right? So what I can do, I mean, I could do it with the x's here, and I'd get a 4 minus 3 or 4 plus 3. I could still do that. But there's something I can do to get them where it's the same here. One of that is to, well, actually, let's go through and see what happens here. Here there was a plus, and here there's not. There's a minus in that. So it's a little bit of a different problem. Okay. I'm going to use blue here on this one. I'm going to start this off the same way as I did the last one. So x times 4x, and the x's cancel, and I get 4 minus 3x. On the bottom, x times 3, that's 3x, and x times the x's cancel. That looks so much the same. If only, this is a plus 4, and that's a minus 4, and that's a negative 3x and a plus 3x. So I can't just, it's not like the same exact thing. So, oh, that's frustrating. But there is something I can do. Okay. And what that is, I'm going to come down here and then sort of show it. Here is mathematically what I'm going to do. Let's take the top one, 4 minus 3x. I'm going to rewrite it. You learned many years ago that every number has a negative inside. So the 4 is actually can be written as negative 1 times negative 4. That is correct, isn't it? 4 is negative 1 times negative 4 multiplies to make a positive 4. Over here with the 3 now, so here so what I want is I want to get a negative 1 for both of these. Then it's negative 3x. So what I can do is I can do a negative 1 times 3x. So that's a plus 3x there, because 3 times 1 is 3. Negative 1 times 3 is negative 3. So what I have here is I have a common factor here. With the negative 1 and negative 4, I have a common factor. The negative 1 of the 3x, I have a common factor. So I'm going to take a negative 1 out, and I have a negative 4 plus 3x. I'm allowed to rewrite this. There's nothing that says I can't switch these two terms around because they're adding and subtracting. Negative 4 plus 3x is the same as 3x minus 4. So what I've just done is I've taken 4 minus 3x and turned it into negative 1, 3x minus 4. If you do this a few times, you recognize immediately that you can do that, take out a negative and change the signs of the things inside it. Because that's all I did. I just took a negative 1 from both. Back up here now. it allows me to take this top part and rewrite it as -1 or -1 times 3x minus 4. And on the bottom, I have a 3x minus 4, and this is multiplying. And because that's multiplying, these two things cancel out, and the answer is -1. So when it looks like this is the stopping point, it's actually not the stopping point, because you can take out a -1 to allow you to then cancel the two things. Doesn't work all the time, but sometimes it does, and this time it did. So I thought that was an interesting thing to look at, and sometimes when you see it, the use of -1 to switch things sometimes becomes useful in certain problems. So you'll like having that in your repertoire of things you can do in math. I hope this helps with seeing these types of things. Thank you for listening.